In the nuclear power industry, radioactive materials are used to generate heat, turning water into steam. As the atoms that make up this matter decay, they give off high-energy particles, which are used for their energy, but are also harmful to human beings. These particles, called radiation, can be measured by a Geiger counter, a handheld device which can determine the amount of radiation and typically determine whether it is alpha, beta, or gamma. In power plants, personnel are typically tasked with going into a room and making a measurement of the radiation at various points. This exposes the personnel to dangerous amounts of radiation. The radiation maps they create are also inaccurate because only certain points are measured. Digital versions of the Geiger counter are also available. They are battery-powered and emit a TTL pulse each time a particle is detected. Integrating this electronic device into an autonomous robot results in a system that is capable of scanning the room for the personnel, removing them from danger. This is the goal of the REMBot project. The REMBot uses sensors such as bumpers, dead reckoning systems, ultrasonic rangefinders, and a digital Geiger counter to scan an entire room, and then download the data onto a personal computer to create a map. The REMBot navigates the room in a serpentine pattern shown here. The green dots represent radioactive sources. This data is collected in the microcontroller and stored for later use. When the REMBot is finished with the scan, it returns to its position of origin, to be collected by the plant personnel. Once collected, the REMBot can be attached to a computer, either via direct USB connection or an external thumb drive. A MATLAB routine then generates a spatial map of the radiation, with red spots correlating to high radiation and blue spots correlating to low radiation. The individual pixels of the mosaic map represent squares of the room that are 6 inches on a side, allowing for simple visual verification of various radiation levels in the room. Over a 9-month period, the REMBot was designed, manufactured, and then assembled by Team REMBot, consisting of Brian Eggenreither, Nick Rhodes, Jeremy Evans, Michael Schmick, and Eric Muniz. The project was completed on April 26, 2010.